Well, now we're beginning to look at functions. We're in chapter section 1.7. And if you recall back from the previous chapter section where we talked about relations, pairing of x and y values. And a function is a relation, but it is a special type of relation. And what makes it special is that for any value of x, for that x, there is only one value of y. And so we're going to look at a few examples here in various types of representations. And this first representation is is mapping. And so we have three mappings here, and we're going to take a look at this. Let's look at the first one. And over here we see that our x value, right here we got an x value. Now we could call that the domain, we can call that the independent variable. All of those mean the same. But we can see here that we've got an x of -6 and it's paired with a y of 4, an x of -2 paired with a y of 1, x with 1, y with -3, and x with 3, y of -5. So we don't see any duplication in our domains here. And they're very neatly, each x is equal to only one y. And so yes, this is a function. Now let's look at the second example here. Well, I'm going to go run down, I'm going to scan through my x values, 5, 2, 0, -3. I don't see any x's repeated, and so that looks pretty good. And so we got 5, when x is 5, y is 4, when x is 2, y is 1, when x is 0, y is -2, and when x is -3, y is 1. And you might say, uh-oh, that means it's not a function. But it is a function. A value of y can be paired with more than one x. It's just that a value of x, I should say, I guess, can only be paired with one value of y. F of x equals 1y. And so, yes, this also is a function. Even though both when x is 2 and when x is -3, they both would give us an output, a y value of 1, it's still a function because the individual x's are only paired with one y. So now, maybe this will be a little bit clearer here on this third example. So I'm scanning down here and I see I've got an x value of 4, 6, and 7. Well, I don't see any repeats there. So that looks pretty good. But look right here at this first x, where x is equal to 4. So it says when x is equal to 4, it could be y is equal to 2 or y is equal to 5. And so here we have an x is paired with more than one y, and so no, that is not a function. It's a relation still, but it is not a function. So let's go look at a couple more. Now, here we see some representations in tables. So again, we got x's and y's. We could call these input, output, domain range, independent variable, dependent variable. All of those mean the same thing. We're going to try to determine by looking at these, are they functions or not. So let's see, I'm going to scan through my x values, 4, -1, 0, 1, 9. That looks pretty good so far. 4, when x is 4, y is -5. When x is -1, y is -10. When x is 0, y is -9. When x is 1, y is -7. And when x is 9, y is 1. And I'm going to say that yes, this is a function. Let's see, let's look at our second example here. Number 5, 2, 5, 3, 4, -, right here, I see I've got x being repeated. And so when x is 5, it's -3, but also when x is 5, y could be 2, and therefore, no, not a function. Let's look at number 6. I can see the same situation as I'm scanning down my x's. I see a 3 here and a 3 here. 3 when x is 3, y is 7, but also when x is 3, y is 5, and that's going to disqualify it. No, it's not a function. Now, another way that we can look at our relations is in the case of ordered pair. So I hope you can see these. So let's see, I've got 2, 4, 3, 5, -2. Now remember, when I'm working inside my parentheses in an ordered pair, the number nearest the left-hand side of the parentheses we treat as an x value, and the number on the right side of the ordered pair, or the one closest to the right side of the parentheses, is a y value. And so I don't see any x's repeated in here. And this is a function. Now I can see here, don't want to cause any confusion, I can see right here x is 2 and y is 5. And when x is -2, y is also 5, but that's okay. It's still a function. Because for a value of x, there is only one y. 2 and -2 are two separate numbers. Now let's look here at number 8. I got x is 6, -4, 5, 4, 6. Okay, 6, when x is 6, -1. And I don't see, I do see an x value repeated. I got an x right, I mean a 6 right here and a 6 right here. That's telling me that when x is 6, y could either be -1 or 5, and so that's going to disqualify it. No, that's not a function. Now let's look at one more situation. I believe it is where we got graphs. Now, when we got graphs, we can apply what is called the vertical line test, which means if I've got a graph and it's connected, this graph and this graph are what we call continuous, because it is connected, the graph is connected by a line or a smooth curve. This is what we call a discrete graph. In other words, we have plots on there, but it's not connected. So we got a continuous and we have discrete. Now, if I've got a continuous graph like this, or even a discrete, if I draw vertical lines through the graph, and those vertical lines only cross that graph at one point, then it is a function. So this one is yes, it is a function. Even though my vertical lines are kind of crooked, can't draw, it still would only cross that graph at one point. Now here I've got a discrete, so let's see, right here I'm good. Only crossing one place, and here it's crossing once, and here it's crossing once. But right here, it crosses, it hits both of those ordered pair, and therefore this would not be a function. All right, last one, we're going to apply the vertical line test. So here we got, it's actually a parabola, but if I start drawing vertical lines, you can see that I'm hitting that graph. I'm crossing the graph with a vertical line in more than one place. And because of that, no, not a function. Okay, that gives us a look. Mapping, tables, ordered pair, and graphs, whether we determine if it is a relation a function.